How are you guys doing? Welcome to the end of day 2 or day 3 for some of you of Data and AI Summit. Thank you for coming out. I know this is a really late session, and it's kind of you to give your time to me to share this with you, so I appreciate that. And first, I kind of apologize for the kind of clickbait title of this session, but it worked. It got you all here, so maybe I'm not sorry. But what I do want to share is, I've really had a mindset shift over the past year about what prompt engineering is and how it can apply. And so I want to kind of walk you through, my thinking on that, and hopefully sway some of you to my camp and kind of how this goes. And when I say my camp, I really mean kind of the brilliant researchers that do the real dirty work. I'm a practitioner. I've worked in business and consulting and for industry. I love retail. And I love applying, other people's ideas to the business that I'm working in. And so that's really kind of my perspective, and certainly standing on the shoulders of giants that do the hard work and the research. So I want to definitely give them credit for what they do. And then finally, I am hiring. So shameless plug. I'm looking for an ML engineering leader who's passionate about retail. And if you fit that or know someone who does, please let me know. All right, let's dive in because I've got about 2 hours of content, and they told me I couldn't go over 40 minutes. We're going to talk about really 4 big areas. First, why agents? So agents are all over the place right now. We talked about them this morning's keynote. It's good that it overlapped. I think that means I'm at least heading in the right direction with the slides I prepared. We'll talk about prompting strategies, about strategies for evaluating those prompts. And then the DSPy framework, which is just phenomenal, and kind of we'll dig into that. And if you're a coder, we'll even get into some code and kind of give you a taste for what you can do with that framework. So that is where we're going. So first, how should we think about building with large language models? So, the magic that GPT provided, or ChatGPT specifically provided in 2022, it's real, right? Like people saw that, people interacted with it. It had this huge hockey stick curve with the way that people saw the value and the potential for value coming from it. So I don't want to take that away by any means, but as a business, like you've got to do something other than hook up to a raw LLM provided by a third party to build something meaningful, right? There is a very quick iteration process that can happen. You can get 80% there really fast in building something cool on top of an LLM, but that last 20% is hard, especially if you're talking about something that's going to be customer facing for you. And I'm seeing the trend and the power of these new models to be better and better, and I think there probably is a future where we have this, artificial general intelligence, this master model that rules it all, and we don't need agents anymore because it's just, it is the thing you need. We're years away from that, and let's embrace the tools we have today to build, good LLM apps. I think one of the other problems with kind of treating it in this approach is there's no intellectual property for your company, right? If you're taking a very simple approach, even in RAG, like RAG's an awesome next step, but there's no IP being generated in what you're doing there, and there's probably a lot of holes and optimization that you can do to continue to improve your systems. And by the way, I'm sourcing all of these on the bottom, and you can't see it. I think Neo4j has this particular diagram. I love the parrot. I love the concept of the parrot as the LLM because the way that it is kind of saying back to you what you want to hear, may or maybe not knowing what it's saying. So the agent approach, this is really about extending that idea of RAG, of you're interacting with more than just the LLM, into a lot of other things, right? Steve Jobs had a quote way back in '97 where he said, when you work with technology, you start with the customer experience, and you work backwards into the technology that feeds that customer experience. I think it's a similar thing when we think about agents. The real power of AI is when it can interact with the world around us. We heard that from Fifi this morning, right? When it can interact with other systems and do stuff for us beyond copying and pasting out of a text box, right? That's when we're gonna get real value and productivity gains. So the LLM is a major component, or the LM, maybe not a large language model, but a normal one, is a big component of this, and probably multiple different types. We've got a fine-tune one, we've got a general purpose one, we've maybe got one from a provider that's kind of in our system somewhere, but we've also got RAG type, knowledge, memory, search, external systems. I loved the demo this morning's keynote around Slack, and actually taking action for me on my behalf. That's all part of this agent approach, and where I think there's real intellectual property that you can build for your business in building these types of systems, because you become less reliant on the tools that are being provided by OpenAI or insert provider here, and you're building the real system that is interacting with the world around you. The flexibility of building an agent is great, because anything we can do with software, we can do with an agent. We can optimize the latency from a technical perspective. We can optimize the interactions with the individual components using some good data science principles. And so it's a really flexible idea for constructing a system, an application that leverages language models. So, first wanted to call out, the DSPy paper is fantastic. I recommend. It's a great introduction into their concepts. Kind of upstream from that is a paper that came out earlier in 23 called, Large Language Models as Optimizers. So the idea of the language model, helping you do optimization of your prompt. And then a recent paper here from a RAG agent, again, where is saying let's extend RAG, and we can really see a lot of benefits from question rewriting, from filtering and re-ranking happening inside of your RAG architecture. So we're not just blindly grabbing some stuff out of vector database and shoving it in a prompt, right? There's so much optimization available there. There's a ton of research that I highly recommend folks find a way to stay current on. There's too much to stay current, so I'm probably missing a ton of stuff here that is continuing to mature in the field. All right, let's shift into prompting strategies. So when we were prompting the LLM, at first there was some good ideas around doing few shot. We're going to actually provide some examples of what we want, but really I think the curve really started with the chain of thought paper that came out and said there's ways that you can ask the LLM to kind of explain its reasoning that actually gets it to a better result, right? Just the fact of asking it to think step by step, suddenly, the actual answer is better. And so, this kind of prompted this whole idea of prompt engineering. Like, let me really tune this prompt to get the result that I want. And so, I've heard job titles around prompt engineering even, right? Like the idea that someone's job is there to type the magic words that the LLM is going to use to spit out the right answer. I think that all of these techniques are very relevant, but really what DSPy provides is a framework that we can interact with these things in a way that's programmatic, rather than blindly hoping that we get the right combination of words. So we'll step through these really quick just so we have a foundation together. Zero shot, I'm literally just asking a question. I'm not providing examples. Few shot, I'm providing examples to the language model. Ask nicely. There's research that you literally, if you say please, it helps. That's kind of wild to me. Chain of thought, I mentioned that earlier. Chain of density, kind of rewriting the amount of interesting facts that are densely populated in a summary. There's react, thinking about taking the next action. Step back prompting. Let me actually rewrite my question in a more generalized way. Prompt injection. Right? This is a type of prompt engineering where we try to break the LLM and get information out of it, or chaining prompts together, kind of sequentially, in order to get the LLM to finally give us what we want. This is an infinitely expanding field. There's lots of great sources that you can go to kind of understand all of these types. So when we think about the prompt, this is where we get into the prompt engineering piece, right? Like, how do we think about how do I know if it's quality or not? So this is a graphic that is on Anthropic's website. And what I want to call out is that the first step is not writing a prompt. The first step, just like the data science process, the first step is the data. Go after the data first. And so getting those edge cases, getting those general cases around what you're trying to solve is the first step to building a language model system. I think that's really critical that you go after those first, rather than going straight to shooting in the dark, hoping that you can find the right combination of words. And then you'll see that evals, right? That circular test against test cases refine the prompt. Like right now, what I see on that image is, I should hire that prompt engineer person to sit there and retype it and see what happens, and retype it and see what happens. And it seems inefficient to me. I'm just going to say we know how to automate some of this stuff, and language models actually are getting good at it. And so that's where this framework is going to come in. One more idea here is, we've come along a journey in software engineering where we found out DevOps is a really good thing. It's really great to automate our deployments, and you'll see, testing is a major step inside of our deployment process, right? There's the pyramid of testing. That at the bottom is the most testing we should do is at the unit level. That we should have fewer and fewer tests the higher up we go in the stack. And then manual test is just the little bitty top of the pyramid, right? Because manual tests are shooting in the dark. You can never get enough surface area in your manual tests to really cover all of your use cases. And so the automation of testing is critical. We've learned that in QE, we've learned that in DevOps. Let's learn that in language model apps too, as we're moving along here. A couple of quotes. This is from a researcher out of VMware. So this is, he built some applications on top of DSPy, trying to evaluate different prompting strategies. And the takeaway was, don't bother trying to figure out that magic combination of words that'll give you the best performance for your task. Just develop a scoring metric and then let the model do it. This is the same method that we use for all algorithms in data science, right? We don't go in there and say, let me fine tune my neural network or fine tune the coefficients of my model. No, we provide it data and we let an algorithm reduce the loss to the point that we have the best model possible. I think Sir Francis Bacon invented the scientific method, and he's probably rolling over in his grave with the fact that we all lost our minds and started just randomly throwing things at LLMs thinking that we're going to get a good system. There's a scientific process that we can follow, that we can use to optimize the system, that we can use for testing. So we'll continue to see improvements in the way that we optimize. I think it's a fairly crude way that we have to optimize today. And so I think that kind of line of research of what does optimization mean will continue to mature, but certainly, in my opinion, something worth adopting now. One more quote from the same article is, a lot of people kind of see LLMs as this kind of person, this sentient thing that speaks English. And under the hood, no, they don't even really speak English. It's a probabilistic model that's doing a lot of math and deciding what the next word should be, right? So it speaks the language of math, not necessarily of English. And this kind of makes me even think, our optimization right now is at the English layer, right? Like we're changing the English words going in, or English for me, maybe not English for all of you, but you were changing those English words going in. Those are getting vectorized, those are getting embedded and then heading into the model. I wonder if there's a future where we don't optimize at the math layer as well. Not a researcher, again, would love to talk to someone that is, like, what is the future look like for how we're optimizing those prompts, ultimately, to get the result that we're looking for. So this is really the key here, is you've got to build a good evaluation strategy, right? So there's some standard metrics. There's some really easy ones, right? Exact match. I can do that very easily, right? I can say, does this number match what I'm looking for? Or is it close to the number I'm looking for? We can do categorization tasks, right? Does this fit the class that I'm looking for? There's some standard metrics out there Bert Score and others that have come along, and you can do anything you want in a programming language to hand tune a metric. And so all of those I would say are possible. There's some new libraries coming out, Ragus, a bunch of others. There's a bunch of SAS tools, Galileo and too many to mention, that kind of can help you in this realm. And then I think one of the really promising ones is have the LLM actually provide a feedback loop, and you could have a separate LLM score the outcomes, and you can actually get more towards kind of a reinforcement learning with human feedback loop here, where you could actually train an LLM and start maybe with that, like train the LLM that's a good discriminator first, and now let me build the system that it can do judging against. And this is where a lot of these systems can come and play. You can do these kinds of things with the standard tools that are out there, but I think DSPy provides a really good framework to do that as well. All right, so let's dig into the framework and why I really fell in love with it last year. First is kind of there's this general workflow. So kind of as you're going through the workflow, you'll see this kind of matches crisp DM if you're from 20 years ago and doing that kind of data science work. It's again the scientific process. We're defining a task, we're collecting some data, setting up our configuration, what language model, what retriever model might be used for RAG. We're defining that metric that we're going to evaluate against. I don't think I called it out, but it was written on the slide. Defining the metric is hard. It's really hard. But that's why you get paid. That's why you have a job, right? Like that's the hard part. And I think that's something that right now requires a human to really think about. And so really making sure you nail that evaluation step is critical. Then you're setting up your pipeline, and that pipeline is for an agent right now. I showed all those possible steps. I think as we mature, we'll want to kind of minimize the number of steps that we step through in any particular interaction, right? So in one interaction, we want to just highlight the 2 or 3 steps that are important for that interaction, rather than running through an entire pipeline. But that's something you can optimize with code and logic as you move along. And then once you've set up that pipeline, now it's time to compile that pipeline or to optimize that pipeline to give you the result that you want. And then finally, save your experiment. Maybe put your metrics in MLflow, and then iterate. Like, what can we do to get it better? There's tons of parameters that we can tune. There's too many hyperparameters that we could spend all of our compute tuning hyperparameters. We've got to be intelligent about which ones we're going to tune. But what are all those parameters going into the model that we can tune? Whether it's the model that you choose, the agent that we can tune, whether it's the model that you choose, whether it's the way that you're calling different tools around the model. I think the tools announcement that we saw this morning in the keynote as well is really interesting. I think there's probably interactions you could do within this framework, within the Databricks framework, that really those individual tools that are reusable. I'm excited to see how that plays into building agents like this. And one more piece of research way back from 2001, and anyone that was a data scientist in the early 2000s, probably saw this graph and kind of it's kind of the foundation for a lot of early data science. But it's that the different lines are different algorithms, right? So the algorithm matters a little bit, but what really matters is the amount of data you feed the algorithm, right? So that's what's on that x-axis. And this is actually, this was really early language work, NLP work that showed this. But the algorithm's way less important than the amount of data. And again, we saw that with ChatGPT, right? Like when they got to GPT 3 or 3.5 and they started feeding it the internet, suddenly it got very, very good. So the amount of data, this applies to LMs, but this can also apply to the optimization that we're doing, right? Let's make sure we have a really good surface area in the test cases and in the training set that we're going to feed the LM or the agent system, so that we have really good capability to get the outcome we want. So why I like working with this framework is it lets me focus on the data rather than focusing on the prompt or focusing on the code. So it's really about the metrics that I'm trying to achieve. It's really simple to configure it inside of Databricks. Databricks notebooks are a great way to do experimentation. You import some libraries, you kind of set up, where are my API endpoints that I want to call if I'm using a model as a service. You can also use a hosted model and stick it in memory. You can use the retriever model, which gives you that RAG implementation, and then just set those configs. And now when you call something inside of DSPy, it's going to use those configs. My original intent when I proposed this topic was kind of contribute to the code base here and provide some Databricks connectors to DSPy. But the community is fantastic. This framework has just really taken off this year, and there's an amazing amount of community support. And so there's already really great connectors for Databricks available that have been developed and released this year. And it's super easy to kind of roll your own connectors inside of Python for any kind of external system because it's a very modular framework and very easy to work with. But for Databricks specifically, very easy to set up their connections to your LMs. And this is any LM that's hosted in Databricks. And kind of a side note here, I really love the I think it's not in GA yet, but the external model serving. So I've got OpenAI endpoints that are exposed behind this, and now the authentication layer is the same as it is for any model hosted on Databricks, right? So I've got models we are hosting on in memory or on servers. We've got models at external vendors. We've got models that Databricks provides, all sitting there. It's just a string that I have to say which model am I calling. So really great abstraction layer that Databricks provides. All right, so now let's actually talk about for DSPy, and as you're getting started, this is a very entry-level concepts here of what are the things that we're going to be able to manipulate in order to get a good prompt engineered by the system rather than us having to do it. So the first one is signatures. Now that's really defining for that particular LM call. What are the inputs and outputs? That's really what you're answering. So, I'm going to give you a question, you're going to give me an answer. I'm going to give you a sentence, you're going to give me its sentiment. I'm going to give you a document, you give me a summary. I'm not going to try to prompt engineer that. I'm just going to tell it what are the inputs and outputs. And then, kind of at the next layer inside of that wrapper around it is the module. The module is where we might implement chain of thought or some other type of prompting technique, just to be able to say, take this input and output, and then wrap around it a task. Inside of that module, you can do incredibly complex things. That's where you can do RAG. That's where you can do an entire agent flow. Anything you can do in code, you can do in this kind of simple class, and we'll actually look at that in a few minutes. And then the real magic, because we haven't actually optimized anything yet, is now we take that pipeline that we've built that has one or multiple signatures, retrievers inside of it. We put it into a module, and then we're going to optimize it because we're going to ask the system to take the data examples that we built and then to construct change the parameters of that pipeline in such a way that it asks the model the right question to get to the answers that we want to have. I think this is really the brilliant part of the framework. You can really do, in a lot of other frameworks, you can do the signatures and modules kind of work. But the optimizers, I think, is a fairly novel concept. Certainly, there are other places to do it, but I think that DSPy is a really great option for it. Let's see. Anything else I want to say here? So same thing. We're following the data science process. We're going to want maybe some train test holdout type of data that we've constructed for our optimizer, right? So we can have some trained data that the optimizer is going to use, and then we want to take it and test the generality against model data that the model's never seen before, kind of during the optimization process. And then, how do we conceptualize optimizers here? Just a couple of things to kind of dig in there is, when you're optimizing, the idea would be that you maybe do some few shot optimization where I inject some examples from my data set into the prompt, and it's going to just programmatically find the right examples that produce the best outcome. In MyPro, that not only kind of does few shot, but also it can help optimize the instruction, right? So it can create a paragraph, and we'll look at that in a minute. Create a paragraph that tells the LM what to do. I'm not going to engineer that prompt. I'm going to let another teacher LM figure out the best prompt that's going to give me the outcome I'm looking for. And then finally, there's even fine tuning. So you can take a small language model in memory and actually take your examples and fine tune it as a really easy way to get started with fine tuning. So it's not just calling the model, but we're actually going to further train the model on the data that we're providing as these examples. And we can do this kind of at any level here. We can do this at a single LLM call. We can kind of optimize at the agent level. We can optimize an LLM call separately and then plug that into an agent as one of the components. So there's just kind of infinite amount of flexibility with the way this is set up. All right, let's dig into some code real quick. If you are not into code, I give you permission to doom scroll on your phone. That's fine. We'll dig in here for just a few minutes and then kind of pique the interest of folks that want to go deeper here. So I grabbed a Hugging Face data set. This is from a Google Research Lab. It is a bunch of Reddit comments that are classified. You can't. I flipped over. Thank you for telling me that. I was going to sit here and talk forever. There we go. Can you guys see that okay? Is it big enough? There's some seats down front. If it's not, I can do one bigger. How's that? Good? All right, good. I got good from the back, so I know I'm good now. All right, I got some Hugging Face data here. It's Reddit comments. Now, I did not think ahead. The internet is not a kind place. And I was just going to use an OpenAI model to show my example here. You would not believe the number of times I got hit with the filter for sensitive content that was in my comments. So I cleaned it up a little bit. I biased my data set away from that, if you will, because that was a major problem when I downloaded this and just blindly sent it into OpenAI. So their content filter works pretty good on Reddit comments, I'll say that. All right, so I'm not going to walk through every step of the code here, but I'm going to give you the highlights. I randomly grabbed 5 different classes here. I noticed that they're very unbalanced, and so I wanted to balance those. So I just went ahead and downsampled those into kind of a static small data set. I also didn't want to blow my company's budget on optimizing a toy problem. So yeah, I used a pretty small data set for our toy example here. But let's take a look at kind of what that data looks like. So I've got some text. Oh, and by the way, these are Reddit comments, and some of them got filtered out, but some of them didn't. So if you are sensitive, maybe just don't read the screen. I haven't necessarily proofed everything here. So we've got some text. That's the first one says it's made yourself vulnerable to being sued. For some reason, by the human, that was labeled as approval. I guess that person's approving the previous comment. Maybe that's what's going on. I am not going to read all of these. I'm going to kind of let you just get a sense for the fact that there was a human that labeled these Reddit comments. And we'll go from there. So, the actual work that we're doing here, we're gonna use DSPy to build a pipeline, and just you can see how easy it is and fast it is to build and iterate on this. So, same thing I showed in the other slide. Most of the lines here are just the parameters for the API call to Databricks. The actual line here shows me the setting up that language model object that I'm going to feed to DSPy to be able to interact with my language model that's hosted or wrapped in Databricks. Because again, this one happens to be GPT 3.5. You could easily just replace that with one of the Databricks native ones or host your own LM. All right, so first thing we're going to do is talk about the data. Remember, so we imported the data. First thing we're going to do now is split the data. So I've used a standard library here. Take that data, randomly segment it into train and test sets. This is one really important concept for formatting that data. So there's actually a wrapper, a Python class that we want to stick that data into. So all this function really does is take this DSPy example class and wrap up our text input and our sentiment label. And then we said, okay, the input for this is the text, as in the features headed into this model is the text. So just looped over that, got all my data out of pandas and into the kind of the native DSPy format there. I've got my train set and my test set ready to go, and we'll reuse those as we move along. All right, next thing we're gonna do, we're gonna define the metric. I cheated here. I just used exact match, right? I'm just trying to do a classification problem. I'm just saying, did you, exactly give me, I'm gonna strip it from spaces and lowercase it, but this is where there's a lot more work to do to really make your system the best it can be. But here, for simplicity, I said, I'm gonna get the example coming in, one of those lists that I just gave. I'm gonna get the prediction going out. I'm gonna see, is the sentiment attribute of both of those the same? If it's the same, I call it a match. So now we're going to move on to the signature, right? So we said this is where you just say, sentence is the input and sentiment is the output. You can also provide a little bit more context here. So this is a specialized class. We're inheriting the signature base class, and we're going to just say, there's a little docstring. I'm going to classify an emotion. I've got an input field. I told it, this input is a Reddit comment. And then I've got an output field, which is an emotion. And I give it a list of those 5 emotions that I wanted to choose from. This is the extent of the prompt engineering that I did, right? There's nothing else that is needed. This is really defining just what are the inputs and outputs that we're going in. So let's take an example now. So I've got, I just grabbed one of my individual examples here. So my favorite food is anything I didn't have to cook myself, and that was labeled as a neutral sentiment in the test set. So if I would just take that and then I wrap this predict function around it and call that sentiment signature that I just created and then send it in, I get a prediction object out, which the LLM said that the sentiment was joy, right? The person was very happy they didn't have to cook themselves. Let's take a look at what actually happened under the hood. So this is just a little debug statement. So this is the actual text that was sent to the LM based on that signature that we defined, right? So that signature, if you recall, it did say that there was a text input. It said that it was Reddit comment. It said that there was a sentiment output. It said that it was an emotion from this list. There's a little bit of template up here, and then this is the actual text I fed in, and it gave me the sentiment joy. So under the hood, that's what's happening at the LM layer. This framework then packaged that up into a defined set of inputs and outputs that I can kind of use in these classes and call in that way. Just as an example, rather than using predict, I can use chain of thought. That's the one where it asked it to explain itself, and it produced this rationale. So it said, it analyzed the statement, and the person's expressing their preference for food they didn't have to cook. Therefore, it suggests that there's convenience and enjoyment to that, and that should produce joy. So now we know why the LM thought this was a joyful statement. And then under the hood again, let's see what actually happened. So very similar step up here. It kind of injected this reasoning step. All I did was say, instead of predict, do chain of thought. And it said, okay, let's think step by step. It produced this reasoning set of lines that got turned into that object on the way back to my framework, and it produced this sentiment, which was joy. So same outcome, just change the signature there. All right, let's go back to building a program now that we can have a little more intuition about how this works. So we need to build a module. So this module right here does the same exact thing as just the DSPy.predict. There's not anything else going on, but this is where the magic could happen, right? Inside of this forward statement, which this is intended to look a lot like folks that are familiar with PyTorch and how that works. But inside of this, you could initialize and act as much logic as you wanted to put in there, and you could call multiple LLMs. This is where that kind of agent idea comes from. and you could do just a ton of logic there. For now, all I've done is really repeat the call to the predict set. There's a ton of really great online guides you can go deep as you want there. But for our purpose, we're just going to prove again. If I now use this predict sentiment module that we just created, we're going to get the same result, right? We're just going to get the sentiment of joy is our prediction. All right. So now that we have our framework, we're able to actually interact with the language model. Let's set up an evaluator. So this is, again, a built-in evaluation function. You could roll your own. You could do a variety of things here. All I've really done is take that. Remember, we defined our metric above, and so I've called out that metric. I've said what set of data I want to use as part of my evaluation. I've said I even want to do it multi-threaded, and then I went ahead and created just a quick function that lets me do that on both train data and test data at the same time. And then differentiating whether I'm calling train data or test data in that evaluation. So we have a zero-shot program, right? We've already defined our signature. We fed it to the model. So let's just go ahead and see what kind of results we get. We get about 20% accuracy on the test set. There's actually some issue with the train accuracy being a little higher in general, but let's just focus on the test accuracy as we go along here, because especially when we get few shot, we're going to kind of leak that data into the prompt, and so don't really want to trust that train accuracy completely. So 20% accuracy at zero shot, that's okay. Probably about the same as random, right? Because we only have 5 categories, if you remember. All right, create a simple few shot program. So I went ahead and imported a couple of really important optimizers here. They used to be called teleprompters. We call them optimizers now. These are the ones you probably want to start with. You can iterate really quickly, though. We're gonna really expand the tasks that we're asking the language model to do very quickly as we iterate through these. So with few shot, we want to provide it some examples, right? We want to say examples of what the prompt should be, or the output should be inside of the prompt. Really all I've done is import this few shot optimizer. I gave it the program that we compiled earlier, and I gave it a train set here. And let's look under the hood and see what's going on. So similar to what we saw earlier. Scroll up here. And I think I had n equals 10 there, so 10 examples of what I asked it to feed the language model. Again, this all looks the same. It's just provided, and went ahead and injected those few shot. I believe these are just the top of my data set, right? It just grabbed the top 10, shoved them in there blindly as our example. When we do that, actually the program does a whole lot better, right? 46%. We've doubled our accuracy just doing few shot. Again, I didn't manually create that prompt. That was something that it did for me based on that training data that I provided it. All right, so let's go a step further. Rather than just shoving the top 10 examples in, and again, 10 was a choice I made there. You could actually optimize on that number, but let's have the algorithm here inside of the framework actually find the best examples to show, right? So that just a couple lines of code, right? It's just this bootstrap optimizer. This really looks the same, predict sentiment, and suddenly I'm up to 50% accuracy, right? Because it kind of iterated through and saw what were the best examples to provide. Couple lines of code. Let's actually go even more advanced. Now this is where I start to caution, though. When you're doing these optimizations, you're gonna be calling your language model a lot, right? Because we're taking a training set, we're calling the language model, we're seeing what results we get back. We're going to iterate on that inside of the optimizer, call the model again, get it back. So just be careful. You can quickly run up a bill if you're using GPT-4 or some of the more expensive models here, and you're calling it a million times. So there's use your brain. That's all I'm going to say. Don't call me if you mess up. So with this bootstrap few shot with random search. There we go. It's gonna search the area for me, and it's gonna provide several trials and try different combinations of few shot that provide a better outcome. So when we do this, we actually end up with 63% accuracy. So every time we're kind of adding complexity to the prompt, we're getting better outcome. We're getting empirically better outcome. It's not somebody sticking their finger in the wind and saying, that looks better, right? It's a search of my test set every time I do this, of the entire test set to say, is this a better outcome or not with the pipeline that I've constructed. And then one more kind of really quick next step would be, all we've done is few shot at this point. We haven't really explored a different instruction that we could provide. So with this MyPro, this is actually instruction optimization. We actually can provide a different language model, the prompt model that can, let's say we use GPT-4, a more powerful model as our trainer. That it can find the right prompt, right? It's going to iterate over during the training process and find a great prompt, and then it's going to teach the task model. Could be a very much smaller model that using this, using the prompt that let's say GPT-4 came up with, we have some small language model that can react to that prompt the best. So this is really where we're outsourcing that prompt engineer job to a language model to do it for us. It gives you a warning here even. Are you sure you want to do this? This is going to call your LM a lot when you invoke this call. But let's just take a really quick look because I'm running out of time at the outcome here. But it produced I'm sorry, I'm in the wrong cell. There we go. It produced a really nice couple of sentences right at the top. That's my prompt instruction to kind of ground it on the task that's being asked. I didn't do the prompt engineering there. I let the language model do the prompt engineering and empirically test what is the best outcome that we can get to. So hopefully that wet your whistle, as we say in the South, for using this framework. And I thank you for your time, and I am out of it. So thank you.